Okay, good morning everyone. Today we'll do what we did last week, and that is given a pair of factors for a polynomial, to write a polynomial given those factors. You actually had a question like this on your test, 5A or 6A, and you'll have a question like this on your 6B test. Okay, so let's just review what you did last week and what you did on your test. So let's say here we had factors of x times x minus 2 times x plus 4, and we want to write a polynomial given those factors. So we first multiply, we FOIL x minus 2 times x plus 4, so that would give us x squared, and then plus 2x minus 8, and then we multiply that by the other factor, x, and so that would give us x cubed plus 2x squared minus 8x. And that would be my polynomial. And as you can see, that polynomial would have zeros of, let's see here, -4, and then 2, which is there, and then 0. Okay, so we'll be doing the same thing today. Well, given factors, or zeros if you will, or roots, to write a polynomial function for that. Okay, so let's begin. So here, the irrational root theorem. It says a lot of verbiage there, but what the irrational root theorem really says is this here. Okay, in solving a quadratic or any type of polynomial, but particularly a quadratic, whenever you solve the quadratic, like when you use a quadratic formula, you got maybe the roots or zeros were something like root 5 plus or minus root 5. And so what the irrational root theorem says is this. When you have irrational roots, you always have a plus or minus, or we say that irrational roots come in pairs. So that was always the case when you got a radical or an irrational root. If you had something like 1 plus root 2, you also had 1 minus root 2. Again, irrational roots, they come in pairs. If you had something like -2 plus root 3, you also had a -2 minus root 3. Again, irrational roots, they always come in pairs. Unlike the roots here, I have 0, 2, and -4. I don't have pairs. But irrational roots, they always come in pairs, and that's what the irrational root theorem says. Okay, so for example, if I had a polynomial x squared minus 5 and I wanted to find the roots, well, I would just set that equal to 0. Or find the zeros. Finding the roots or finding the zeros is the same. So I would add 5 to both sides, and then I would take the square root of both sides, and I would get x is equal to plus or minus root 5. Again, irrational roots, they come in pairs. So what we want to be able to do, though, is we want to be able to, given roots, particularly irrational roots, to write a polynomial. So basically, we'll just be going in reverse. So given roots of x is equal to plus or minus root 5, let's write a polynomial. So the way we would do this is that we would just kind of reverse the process here. Okay, so when I solved for x here, I took the square root. Well, I'll just reverse what I did when I solved. So here, I'll square things. I'll square both sides. And so I'll have x squared. Now, if I take a positive and square it, I get a positive. And if I take a negative and square it, I get a positive. So this here, this just becomes positive. But then the square root of 5 squared, that's just equal to 5. Or the square root of 5 squared is equal to the square root of 5 times the square root of 5, which is equal to the square root of 25, which is just 5. So this will equal 5 then. Okay, so then to write my polynomial, all I do is subtract the 5. So f of x is equal to x squared minus 5. So notice here again, all I did was really reverse the process. Okay. Given x squared minus 5, I found the zeros to be plus or minus root 5 by taking the square root. But given roots of plus or minus root 5, I just reverse the process. I square, and then I subtract. In number 1, I added 5, and in this one here, number 2, I actually subtracted 5. I'm just reversing the process. All right, so let's take a look at the next one here. Given roots of x is equal to plus or minus root 3, let's write a polynomial. So again, I have x is equal to plus or minus root 3. I'll square both sides. And so that will give me x squared is equal to the square root of 3 squared is just 3. So now I'll subtract 3, and I'll have my polynomial. Guaranteed to have roots of plus or minus root 3. Guaranteed. Let's do the next one. Given roots of x is equal to 1 plus or minus root 5, write a polynomial. So again, if x is equal to 1 plus or minus root 5. Again, I'll just reverse the process. When I actually found the roots, 1 plus or minus root 5, the last thing I would have done would have been to add 1. So the first thing I'll do is subtract 1. So x minus 1 equals plus or minus root 5. Now we just square both sides. Again, we're just reversing the process. So x minus 1 squared is a perfect square trinomial, so x squared minus 2x plus 1. And then the square root of 5 squared is just 5. Now if I subtract 5, I'll have my polynomial. X squared minus 2x minus 4. Okay, and that polynomial is guaranteed to give me roots of 1 plus or minus root 5. And then let's look at one more here. So given roots of x is equal to negative 2 plus or minus root 7, I want to write a polynomial. So I'll start. So x equals negative 2 plus or minus root 7. So add 2. So I'll have x plus 2 equals plus or minus root 7. Now I'll FOIL, I'll square both sides, and FOIL the left side. So x plus 2 squared is x plus 2 times x plus 2, or that's going to be x squared plus 4x plus 4, and the square root of 7 squared is just 7. And then when I subtract 7, I'll have x squared plus 4x minus 3. And there's my polynomial guaranteed to give me negative 2 plus or minus root 7. Give me roots of negative 2 plus or minus root 7. So again, irrational roots, they always come in pairs. Now let's look at imaginary roots. Well, believe it or not, imaginary roots, they come in pairs too. That's a complex conjugate root theorem. So anytime we solved and we got imaginary roots or complex roots, they always came in pairs. So if I had a 3i as a root, I also had a negative 3i. If I had 2 plus 3i root 7, then I would have also had a 2 minus 3i root 7. If I had a negative 4 plus 5i, I would have had a negative 4 minus 5i. Okay. Again, imaginary roots, they come in pairs too. Plus or minus, plus minus, plus minus. Okay, so writing a polynomial given imaginary roots is really no different than what we just did with irrational roots. So let's say here I have the roots are plus or minus 2i. So I want to write a polynomial with those roots. So I have x is equal to plus or minus 2i. Again, I have to square both sides. And so I get x squared is equal to, so I'll have 2 squared, and then I'll have I squared. I need to square both the 2 and the I. Well, 2 squared though is just 4, and I squared is negative 1. So this is going to equal negative 4. 2i squared is just negative 4. And then when I add 4, I'll have my polynomial. F of x is equal to x squared plus 4. So that polynomial x squared plus 4 is guaranteed to give me roots of plus or minus 2i. And then let's look at the other one. And again, the process is just the same as we saw for irrational roots. So here I have x equals negative 2 plus or minus 3i. And I want to write a polynomial given those roots. So I'll add 2. So x plus 2 equals plus or minus 3i. Okay, so now I have to square both sides. And so x plus 2 squared will be x squared plus 4x plus 4, and then 3i squared, well, that would be negative 9. 3 squared is 9, and I squared is negative 1, and 9 times negative 1 is negative 9. So now I add 9, and I'll get my polynomial. Okay, and that polynomial is guaranteed to have zeros or roots of negative 2 plus or minus 3i. Guaranteed. Okay, so let's put everything together now. You know, when I started this, I started with, when we had rational roots, I had 3 factors, or 3 zeros, 0, 2, negative 4. And so now we'll just have a lot of zeros again, except some of them will be irrational roots and some of them will be imaginary. So let's say here I want to write a polynomial with the roots of 0, negative 2, and 1 plus or minus 3, root 3. So, well, the factor for 0, that will be x. The factor for negative 2, that would be x plus 2. So I can start to multiply that, and that will be x squared plus 2x. Okay? But we have to find a factor for 1 plus or minus root 3. So my roots are 1 plus or minus root 3. So again, we have to write a polynomial with those irrational roots. So first thing I do is I subtract 1. Then I square both sides. And so x minus 1 squared will be x squared minus 2x plus 1. And then the square root of 3 squared, well, that would just be 3. And then I subtract 3, and I'll have x squared minus 2x minus 2. All right, so what I'll do is I'll take that and that and multiply them together. So I have x squared plus 2x times x squared minus 2x minus 2. So let's distribute. So that to that, that to that, that to that, and then that to that, that to that, and that to that. So x squared times x squared is x to the 4th. X squared minus 2x is minus 2x cubed. And then x squared times a negative 2 is negative 2x squared. Okay, and then 2x times x squared is 2x cubed. And then 2x times negative 2x is negative 4x squared. And 2x times negative 2 will be a minus 4x, negative 4x. And so my polynomial will equal x to the 4th minus 6x squared minus 4x. And that polynomial, it's a 4th degree polynomial, okay, I have 4 zeros, or 4 roots, guaranteed to have the roots of 0, negative 2, and 1 plus or minus root 3. Guaranteed. And then finally, let's say here I have a polynomial with these roots here. So negative 2 plus or minus root 5, and then 3 plus or minus 4i. So again, we have to find the factors for those roots. So I'll start with the irrational roots. So x equals 2, negative 2 plus or minus root 5. I'll add 2. I'll get x plus 2 equals plus or minus root 5. I'll square both sides. And then this would be x squared plus 4x plus 4. When I FOIL x plus 2 squared, and then that will equal 5, because the square root of 5 squared is just 5. And then when I subtract 5, I'll get x squared plus 4x minus 1. So that's 1. And then I have to do the same thing for the imaginary roots, the complex roots. So x equals 3 plus or minus 4i. I have to subtract 3. X minus 3 equals plus or minus 4i. Now I have to square both sides. And then FOIL x minus 3 squared. That will be x squared minus 6x plus 9. And then 4 squared is 16, and I squared is negative 1, so this would be negative 16. Add the 16 on both sides, and I'll get x squared minus 6x plus 25. Okay, and so then I'll have to multiply everything together. And this is where I'll use the box method. Find it much easier to organize things here. Okay, so I have my x squared, my 4x, and my minus 1, and my x squared, negative 6x, and 25. And then when I multiply x to the 4th, this is 4x cubed, and then x squared times negative 1 is negative x squared. And then negative 6x times x squared would be negative 6x cubed. And then negative 6x times 4x would be negative 24x squared. Negative 6x times negative 1 will be a positive 6x. 25 times x squared will be 25x squared. 25 times 4x will be 100x. And then 25 times negative 1 will be negative 25. And then I'll add on the diagonals. So the polynomial I will get will be x to the 4th, and then minus 2x cubed, and then nothing for x squared, and then plus 106x, and then finally minus 25. And that polynomial will be guaranteed to have zeros of negative 2 plus or minus the square root of 5, and 3 plus or minus 4i. Okay, so again, basically it's just finding the zeros in reverse. We're just reversing the process of what we would have done when we found the zeros.